Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 14 video on the chapter of mensuration, where I will discuss about how to find the area of a parallelogram. And finally, I will solve 4 example problems based on the concept of finding the area of a parallelogram. If you have not watched the previous 13 part 1 to part 13 videos on this chapter of mensuration, then I strongly suggest and request that you please watch them also, so that you will have a good continuity on your study on the chapter of mensuration. So this video is part of the playlist CBSE Maths for class 7 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with the part 14 video on the chapter of mensuration, where I will discuss about area of a parallelogram. Okay, so on the left hand side I have prepared a quick notes about the concept of finding the area of a parallelogram, and I have at the end 4 example problems that I will solve and discuss on the right hand side. Okay, so to understand the area of a parallelogram, we need to understand first what is a base and height of a parallelogram. Now, as you can see on the left hand side, I have explained, I have 2 diagrams, diagram 1 and diagram 2, where the parallelogram is ABCD, it is the same, but I have explained the bases and height in a different way. That is, let's say, let's draw the parallelogram. Let's say I have this parallelogram. Please note that my figure will not be exact, it will be very approximate. So ABCD is the parallelogram. ABCD is a parallelogram where AD is parallel to BC and AB is parallel to DC. Now we know that in a parallelogram there are two pair of opposite parallel sides. So one pair of any pair of opposite parallel side can be considered as the base of a parallelogram. So and the corresponding height of the parallelogram will be the perpendicular distance between the 2 parallel opposite sides. So since in a parallelogram there are 2 pairs of opposite parallel sides, in a parallelogram there will be 2 pairs of a base and its corresponding height. Okay, so let's understand. As you can see on the left hand side, I have let's say this parallelogram ABCD, the side AB, let's say AB and DC, the length is equal to y, and let's say AD is equal to BC, their length is x. Now if I consider the parallel sides AD and BC, then the base will be consider. Okay, I am explaining the base and height as per the diagram 1. Okay, so in this case the base, I am considering the parallel sides, the opposite parallel sides AD and BC. So the base is in a parallelogram, and the base is normally denoted by the length of the base is normally denoted by the letter small b. So the base will be equal to AD, which is equal to BC. So the base is considering the opposite parallel sides AD and BC as the base. So the base B will be equal to AD and BC. Now what will be the corresponding height when the base is AD or BC? It will be the perpendicular distance. So the height which is denoted by small h will be equal to the perpendicular distance between AD and BC. Since we are considering AD and BC as the base, the corresponding height will be the perpendicular distance between the sides AD and BC. So, what will be the perpendicular distance between AD and BC? It will be, if I drop from the vertex A, if I drop a perpendicular on BC, let's say AE is perpendicular to BC. So AE, the length of AE will be the height. So this will be equal to AE. Now there can be the height. This height AE can be measured or drawn in various ways. For example, so AE is one way of drawing the height between height of the parallelogram when the base is equal to AD and BC. So that is AE, the line segment AE must be perpendicular to both AD and BC. Now one concept you must know, that when we have two parallel lines, let's say these are two parallel lines L1 and L2. These are two parallel lines. Now how do we measure the perpendicular distance between these two parallel lines L1 and L2? We draw a line which should be perpendicular to any of this, which will be perpendicular to both the line L1 and L2. Let's say I draw this is the line, let's say PQ, where PQ is perpendicular to the line L1 as well as PQ is perpendicular to line L2. So therefore PQ, PQ, the length of the line segment PQ will be the height of, will be the perpendicular distance between the parallel lines L1 and L2. Now as you can understand that I can draw, there can be numerous since like PQ there can be numerous other line segments which will be perpendicular to both the lines L1 and L2. For example, I can extend, if I extend the line L1 L2, I can have here let's say RS, this line RS which is drawn perpendicular to the line L1 and L2, the RS will also be the perpendicular distance between the line L1 and L2. Similarly, since in the parallelogram AD is parallel to BC, one perpendicular distance between them is AE. Similarly, I can draw another perpendicular distance that I can draw between the parallel lines AD and BC can be, I can extend the side BC, and from the vertex A I can draw a perpendicular on the extended BC, let's say this point B F. So I can also say that the height of this parallelogram when the base is AD or BC will also be equal to DF. So this is just to explain that the distance between the two opposite parallel sides of a parallelogram can be drawn or visually shown in multiple ways. AE is one way, AE and DF are two ways of drawing the perpendicular distance between the opposite parallel lines AD and the opposite parallel sides AD and BC. So when we are considering the opposite parallel sides AD or BC, AD and BC as the base, the corresponding height will be the perpendicular distance between AD and BC, which in this diagram is equal to AE and or DF. Okay. Now let's try to understand what if we consider the other pair of opposite parallel sides, that is AB and DC as the base. What will be the height? Okay. So this is I am explaining the figure 2 on the left hand side. So let's draw the same parallelogram. This is the same parallelogram. It may not look the same, but please assume that this is the same parallelogram AB CD. Now I am considering the opposite parallel sides AB and DC as the base. So now the base B is equal to AB or DC. I am considering the other pair of opposite parallel sides AB and DC as the base. Okay. Now what will be the height? Definitely the height, the corresponding height will be the perpendicular distance between the opposite parallel sides AB and DC. So it will be, I can, from vertex A, I can draw a perpendicular on the side DC. So this is perpendicular, let's say this is AE. So height H will be equal to perpendicular distance between AB and DC, which as per the diagram can be equal to, which is equal to AE, since AE is perpendicular to both the opposite parallel sides AB and DC. So AE will be the perpendicular distance between AB and DC. Now similarly, I can draw many other perpendicular distances between the sides AB and DC. Like I can, for example, I can okay, so another distance, another perpendicular distance can be that I can drop a perpendicular from the vertex C on the side AB. So let's say this point BF. So considering a base as the opposite parallel sides AB and DC, the height, the corresponding height can also be FC. Since FC is the perpendicular distance between the parallel opposite sides AB and DC, which are considered as the base. Some other perpendicular distances can be, if I extend the side DC this way, and I can drop a perpendicular from vertex B to on the extended DC, on the extended side BC. This is perpendicular, let's say this point B G. So the perpendicular distance between the pair of opposite parallel sides AB and DC will also be equal to BG. Likewise, I can, let's say, if I extend the side AB and I drop a perpendicular from the vertex D on the extended AB, this is perpendicular, and let's say this point BG, not G, BH, then I can say that DH will also be the perpendicular distance between the sides, between the pair of opposite parallel sides AB and DC. So when we are considering AB and DC as the base, then AE, FC, BG and DH will be the corresponding height. I hope it is now clear what is a base and height of a parallelogram. So in any parallelogram there are two pairs of a base and corresponding height. Okay. Now what is the formula for area of a parallelogram? The area of a parallelogram is equal to the product of the base and height. Now since the product of base and height, that is the corresponding height. So in the figure 1, for figure 1, let's say the height, let's say the perpendicular, the height, that is AE and DF, be equals to H1. So for the figure 1, considering the base as base as the pair of opposite parallel sides AD and BC, the area will be equal to base, that is base is x multiplied by the height, the corresponding height, which is h1, where we have AE and let's say this is y. AE and DF are h1. So for figure 1, considering the side AD and BC as the base, and the corresponding heights being AE and DF, which is equal to h1, I can say that the area will be x multiplied by h1, where h1 is the height or the perpendicular distance between the sides AD and BC. Okay, and for the figure 2, the area will be equal to the base, with the base. Now in this figure 2, the base we are considering as the pair of opposite parallel sides AB and DC, which are equal to y, as per the diagram, as per the diagram given, as per the dimensions given in the diagram on the left hand side. Okay, so the area will be now the base multiplied by the height. Let's consider the height in the second diagram. The height AE and FC, BG and DH, they are equal to H2. So the height, so the area will be now y multiplied by H2, where y is the length of the pair of opposite parallel sides AB and DC, which is the base, and H2 is the distance, perpendicular distance between the sides AB and DC, which we are considering to be H2. So basically the area of a parallelogram is base into height. Depending on the height will be the corresponding height. So since there are two bases, you can consider two bases. So the height will be depend on the base, that is the perpendicular distance between the two parallel opposite sides, which we have considered to be the base. So this is all about the area of finding the area of a parallelogram. Okay, now let's solve the 4 example problems. Okay, the first problem says that there is a figure, ABCD is a parallelogram. ABCD is a parallelogram such that AB is parallel to DC, okay, and AD is parallel to BC, okay, and AE, there is a line segment AE which is perpendicular to BC. So AE is perpendicular to BC. AE is perpendicular to BC, which means that AE is the perpendicular distance between the, which means that AE is perpendicular distance between AD and BC, okay, and CF is perpendicular to AD. CF is perpendicular to AD. Now please note that since it is only given that in the problem AE is perpendicular to BC, now if AE is perpendicular to BC, AE will also be perpendicular to AD, because AD and BC are parallel. A side concept that if let's say if the line segment PQ is parallel to, let's say, QR, and let's say AB is perpendicular to PQ, this will also imply that AB is perpendicular to QR. So if one line segment is perpendicular to one of the two parallel lines, then it will also be perpendicular to the other parallel line. Okay, so we must have CF is perpendicular distance between AD CF is perpendicular distance, and CF is perpendicular to AD. Okay. If area of triangle BDC, if if area of triangle BDC is A square units, AE is equal to H1, AE is equal to H1 and FC is equal to H2. Then perimeter of parallelogram ABCD is, then perimeter of parallelogram ABCD is, I think there is a small mistake in the problem. The perpendicular CF CF, there is a problem in the, there is a little issue in the problem. I'm sorry, I did a mistake in framing the question. The CF should be perpendicular to AB. So the diagram should be like this. We have the parallelogram ABCD, A, B, C, D. So we have AE. So definite. Okay. So AE is perpendicular to BC, and it will be CF like this. CF is perpendicular to AB. CF is perpendicular to AB. This should be the proper diagram. So now it is given that if area of triangle BDC, that is BD is the diagonal of the parallelogram. If area of the triangle BDC is A square units and AE is equal to AE, it is given that AE is equal to H1 and CF is equal to H2. CF is equal to H2. Then perimeter of parallelogram ABCD. It is asking to find the perimeter of the parallelogram ABCD, meaning we have to find somehow either the dimensions of the adjacent sides or the sum of their the lengths of the adjacent sides. So let's say here, this side AD, this side, the length of the adjacent sides of this parallelogram be x. So this is x, let's say, and let's say this be y. So we are assuming let AD is equal to x and DC be equal to y. Okay. We have to find perimeter, perimeter P of ABCD of the parallelogram, perimeter then of the parallelogram ABCD will be equal to 2 multiplied by x plus y. We know that the area of a parallelogram is 2 into the sum of the adjacent sides. Okay. So somehow we have to find x plus y, or we have to find individually x and y. Okay. What is given? The if okay. So AE is perpendicular distance between AD and BC, and we have CF. CF is perpendicular distance between AB and DC, and it is given that the area I am denoting the area of triangle BDC as AR, triangle BDC, it is given as A. Okay. Now Please note that in a parallelogram, any diagonal divides, a diagonal in a parallelogram divides the parallelogram into two congruent triangles. And congruent, the area of congruent triangles are equal. So we must have that triangle. So we must have area. Okay. So BD is a diagonal. BD is a diagonal. So this implies that area of triangle BDC should be equal to half the area of the parallelogram ABCD. Since the diagonal BD is dividing the parallelogram ABCD into the triangles ADB and BDC, and the area of congruent triangles are equal, we can say that the area of triangle BDC will be equal to half the area of parallelogram ABCD. So this implies we can say that area of parallelogram ABCD will be equal to twice A, as it is given the area of triangle BDC is A. Okay. Now how do we find x and y, or x plus y? Okay, so we know the area of the parallelogram ABCD, and we also know the distances between the perpendicular distances between the two pair of opposite parallel sides. Now I can also say that area, based on the formula of area of a parallelogram is product of base and height. I can say area of parallelogram ABCD considering AB and DC as the base, and FC as the height. I can say the area of parallelogram ABCD will be y, since the length of the opposite parallel sides AB and DC is y, as per our assumption, y multiplied by FC, which I have assumed to be H2. Okay. So this is equal to twice A. So this implies that y should be equal to twice A by H2. Similarly, area, again I can say, considering the other pair of opposite parallel sides as the base, that is area of parallelogram ABCD will also be equal to x multiplied. What is x? X is the length of the opposite parallel sides AD and BC, and the perpendicular distance between the sides AD and BC is AE, which is H1. So I can say this will be H1. This is equal to twice A. So this implies that x is equal to twice A by H1. So I have found x and y, that is the dimensions of the adjacent sides of the parallelogram, in terms of A and H1 and H2. Okay. Now, so this implies perimeter of the parallelogram ABCD will be equal to 2 multiplied by x plus y, which is equal to 2 multiplied by, what is x? X is twice A by H1, and what is y? Y is twice A by H2. If you simplify this, this will be equal to 4A. This will be equal to 4A. 4A. This will be 4A multiplied by H1 plus H2 whole divided by H1 multiplied by H2. So 4A multiplied by H1 plus H2 whole divided by H1 by H2 will be the perimeter of the parallelogram ABCD. So the correct choice So the correct choice will be D. D is the correct choice. Okay, let's do the next problem. Question number 2 says a wire of length L is bent into a shape of a parallelogram ABCD, where AB is parallel to CD and AD is parallel to BC. So let's draw the parallelogram. So AB is parallel to CD. So AB is parallel to CD. So this is the parallelogram that is formed from the wire of length L. Okay, and distance between AB and CD, distance between AB and CD is N. Distance between AB and CD, let's say, so this is the distance between, let's say, CE is perpendicular. So CE is drawn perpendicular to AB. So this implies that CE is the perpendicular distance between AB and CD, which is given to be M. Okay, and distance between AD and BC is N. AD and BC. So let's say let's drop a perpendicular from C to AD. So this is perpendicular. Let's say this be F. So CF is drawn perpendicular to AD. So this implies that CF is the perpendicular distance between AD and BC, which is given to be N. Okay, and it is given that M is greater than N. M is greater than N. Okay, then the length of longer side of parallelogram ABCD is, then the length of a longer side of parallelogram ABCD. Okay, now since this parallelogram ABCD is formed from a wire of length L, we can say that perimeter of the parallelogram ABCD is equal to L. This implies, let's say the side the length of the opposite parallel sides AD and BC is equal to X, and let's say the length of the other pair of opposite parallel sides AB and DC be equal to Y. So we will have the perimeter of the parallelogram ABCD will be 2 multiplied by X plus Y, and this is equal to L. So this implies that X plus Y is equal to L by 2. Okay, so we have got the sum of the adjacent lengths of the parallelogram is equal to L by 2. Okay, now we have to also use the information that the perpendicular distance between the two pair of opposite parallel sides are given. So based using that information, I can say that area of parallelogram ABCD will be equal to, I can say, considering the base as the sides AB and DC, that is the opposite parallel sides AB and DC. If I consider that as the base, the area will be Y multiplied by the distance between AB and DC, which is CE, which is M. Okay, and also I can say that the area of the parallelogram ABCD, considering the pair of opposite parallel sides AD and BC to be the base, and their base and the corresponding height, which is the perpendicular distance between AD and BC, which is CF, which is n. So n. So I can see that the area of the parallelogram ABCD is equal to y into m, and also it is equal to x into n. So I can say that ym, this is equal to ym, and this is equal to xn. So I can say ym is equal to xn. So this implies I can have the ratio between x and y. So I can say now x by y will be equal to m by n. Now using this ratio x by y and the sum of the values of x plus y, I can easily find the individual values of x and y using the concept of ratio and proportion. Okay, so this implies that if x by x, okay, so x by y is equal to m by n. So this implies that x is to y is equal to m is to n. And also I know using this information that x is to y is equal to m is to n, and x plus y is equal to L plus 2. From the concept of ratio and proportion, I can say that x will be equal to m. The x is to y is x is to y is equal to m is to n. So the value of x will be m by m plus n whole multiplied by the sum of the values of x plus y, that is L by 2, which is equal to ml divided by twice of m plus n. So this is x. Similarly, y will be equal to n by m plus n multiplied by L by 2. This is equal to nl divided by twice of m plus n. Now we have to see which is greater, x or y. Clearly, since it is given that m is greater than n, m is greater than n implies that m L will be greater than n L. So this implies that m L divided by as you can see in both the values of x and y, the denominator is a constant, that is the denominator is the same, that is 2 into m plus n, but the numerator are different. The numerator for x is ml and the numerator for y is nl, and then so the numerator of the values of x and y is will differentiate whether x is greater or y is greater. So I will, and now I can say that since m is greater than n, I must have L is constant, so m into L must be greater than n into L. And again I can divide this inequality by 2 into m plus n. So I will have this greater than NL divided by 2 product of this. So this implies what is ml divided by 2 into m plus n, that is x. So this implies x is greater than y. So the length of the longer side of the parallelogram is x, which is ml divided by 2 into m plus n. Hence the correct choice is C. C is the correct choice. Okay, let's do the next problem, problem number 3. So a figure is given, PQRS is a square having area of A square units. PQRS is a square having area of A square units. RT meets extended PS at T such that RT is parallel to QS. RT is parallel to QS. Okay, so RT is drawn parallel to QS and it meets the extended PS at the point T. Find length of SO. Find length of SO if SO is perpendicular to RT. Okay, so we have the square uh, we have this square. Okay. Okay. So we have this square PQRS. PQRS is a square. Okay. And QS is the diagonal. Okay. QS is the diagonal, and RT is drawn parallel to QS. RT is drawn parallel to QS. So QS and RT, the line parallel to QS, which is drawn from R, meets the extended side PS at T. Okay. So this is T. Fine. And SO is perpendicular to RT. Okay. So we have SO perpendicular to RT, and we have RT parallel to QS. Okay. Now, we can clearly see that in the quadrilateral SQ RT, we are having, since ST is an extended side of PS, we will have ST is parallel to QR. Since PQRS is a square, so QR is parallel to PS. So definitely QR will also be parallel to ST. And it is given that QS is parallel to RT. So this implies that SQ RT is a parallelogram, where QS is parallel to RT and ST is parallel to QR. So ST is parallel to QR. So definitely SO, so this implies SO is a perpendicular distance. SO is perpendicular distance between the pair of opposite parallel sides QS and RT in the parallelogram SQRT. Okay. It is asking find out length of SO. We have to find length of SO. Okay. The area of PQRS, the square, the area of the PQRS is a square having area of A square units. Now to find SO, we need to find SO, length of SO, we have to find the area of the parallelogram SQRT. To know to find the area of the parallelogram SQRT, we need to find the base, the length of the base, which is QS or RT. Okay. Now PQRS is a square having area A. Now okay. So PQRS is a square, and area of PQRS is given to be equal to A. We know that we have already discussed while discussing area and perimeter of a square, that for a square area is equal to diagonal square by 2. For a square, the area is equal to the length of the diagonal, the square of the length of the diagonal divided by 2. So for the square PQRS, we must have A is equal to QS. QS is the diagonal, QS square by 2. So this implies that QS square should be equal to twice A. This implies that QS will be equal to square root of twice A. QS, that is the diagonal of the square PQRS, will be equal to square root of twice A. So this is a standard formula. If A is the area of any square, then the length of the diagonal is square root of twice A. So now what is QS? So we have found QS, which can be considered as the base of the parallelogram SQRT, and that is since QS and RT are the one pair of opposite parallel sides, and so they can be considered as the base, and the corresponding height, that is the distance between the parallel sides QS and RT, is SO, and we have to find the length of SO. Okay, now how do we so we know we have to find SO, so we have found QS. Now to find SO, we need to know the area of the parallelogram SQRT. Okay, now please note that any diagonal of a square, the diagonal of a square divides the square into two equal halves, that is into two equal two congruent triangles. So we must have area of triangle SQR, area of triangle SQR will be equal to area of triangle PQS, and they must be equal to area half into area of the square PQRS, which is equal to area of the square PQRS is given to be A, so this will be equal to A by 2. So the area of the triangle PQS and SQR, they are congruent triangles, since these triangles are formed by the diagonal QS of the square PQRS, and the area of two congruent triangles are equal. So we must have the area of triangle SQR is equal to the area of triangle PQS, and they must be equal to half of the area of the square PQRS, which is equal to A by 2. Okay. Now also see that SR is the diagonal of the SR is a diagonal of the parallelogram SQRT. SR is the diagonal of the parallelogram SQRT. So this will imply in a parallelogram also the diagonal divides a parallelogram into two congruent triangles. So we must have area of triangle SQR should be equal to half the area of the parallelogram SQRT. This implies, we know that the area of the triangle SQR is equal to A by 2. So we must have A by 2 is equal to half the area of parallelogram SQRT. From here we can easily find the area of the parallelogram SQRT. So the area of parallelogram SQRT will be equal to A. So now also we know that the area of parallelogram SQRT using the formula base into height will be equal to QS multiplied by SO, which is equal to what was QS? QS was square root of 2A, which is equal to square root of 2A multiplied by SO. So this implies what is area of parallelogram SQRT? It is A. So this implies A is equal to square root of twice A multiplied by SO. So from here we can get SO. SO will be equal to A by square root of twice A. This is equal to, if you simplify it, it will be equal to square root of A by 2. So the correct choice is C. C is the correct choice. Okay, let's do the last problem. Question number 4. ABCD is a rectangle. ABCD is a rectangle where AD is equal to BC is equal to 3x. Okay, so the length is given to be 3x and the breadth is given to be twice x in the of the rectangle ABCD, and BE is parallel to FD. Okay, so let's quickly draw the diagram. So we have the rectangle. We have the rectangle ABCD. A, B, CD is the rectangle where it is given the length is x, the length is 3x, and the breadth is 2x. And we have this line BE and DF are parallel to each other. That is BE and DF are parallel to each other, and obviously since ABCD is the rectangle, we will always have it is parallel to BC, which means that EBFD is a parallelogram. EBFD is a parallelogram. Okay, where we have ED is parallel to BF and BE is parallel to DF. BE is parallel to DF, this is given, and by the fact that ED is part of the side AD and BF is part of the side BC, ED will be parallel to BC. ED will be parallel to BF. So EBFD is a parallelogram. Okay, and also notice that AD, AB or DC is a perpendicular distance. Since ABCD is a rectangle, AB is perpendicular to both AD and BC. So therefore, AB will be perpendicular to ED and BF, which means that AB or CD is the perpendicular distance between ED and BF. Okay. Okay, so what is given now? If area of the rectangle ABCD is 5 by 4 times area of EBFD is a parallelogram. Okay, so it is given that area of ABCD, that is the rectangle ABCD, area of rectangle ABCD is equal to 5 by 4 times the area of EBFD, which is the parallelogram. This is given, and also it is given AE is to ED is equal to 1 is to P. Then find the value of P. Okay, so it is given that AE is to ED. It is given that AE by ED is equal to 1 by P. Then we have to find the value of P. So that means that I have to find the value of what is the ratio of AE and ED. AE and ED. So I have to find AE, ED. ED is the one side of the parallelogram EBFD. Okay. Now, okay, so okay, so the area of the rectangle ABCD and is 5 by 4 times the area of EBFD. Now, what will be the area of the parallelogram EBFD? EBFD. We need to know if we consider so in parallelogram EBFD, in parallelogram EBFD, okay, before that, since we know we can find the area, so what will be the area? Okay, so we can say that area of parallelogram EBFD will be equal to 4 by 5 times area of the rectangle ABCD. The length and breadth of the rectangle ABCD are given, so we can find its area. So this is 4 by 5 multiplied by, what is the area of the rectangle ABCD? It is 3x multiplied by 2x. So this is equal to 24 x square by 5 is the area of the parallelogram EBFD. Okay, fine. Okay, also we can say that from the concept of the area of a parallelogram to be product of base and height, we can say that the area of the parallelogram EBFD will be equal to, if we consider the base in the parallelogram EBFD to be the parallel sides ED and BF, we can say that it will be ED multiplied by the perpendicular distance between the parallel opposite sides ED and BC. ED and BF is nothing but AB or TC, which is 2x. So this implies we have ED multiplied by 2x is equal to 24 x square by 5. So from here we can find ED. So this implies ED is equal to ED will be equal to 12x by 5. So ED is equal to 12x by 5. Okay, ED is equal to 12x by 5. Okay, so what will be, this implies what will be AE? AE is equal to AD minus ED. AD minus ED, which is equal to, what is AD? AD is the length of the rectangle, which is equal to 3x. So this is 3x minus ED. ED is 12x by 5, which is equal to 3x by 5. Okay, so AE is equal to 3x by 5 and ED is equal to 12x by 5. So this implies that AE divided by ED is equal to 3x by 5, this divided by 12x by 5. If you simplify this, it will be 1 by 4. Okay, so AE by ED is equal to 1 by 4. Now AE by ED is given to be 1 by P. So this implies that 1 by P is equal to 1 by 4. This clearly implies that P is equal to 4. P is equal to 4. So the correct choice is D. The value of P is 4. Okay. So with this, it comes to an end in discussing the area of a parallelogram along with 4 example problems to illustrate how to apply the concept of area of a parallelogram. So the area of a parallelogram, the formula is product of the base and height, where the base you can consider as any one of the length of any one pair of opposite parallel sides. So in parallelogram there are two pair of opposite parallel sides. So you can consider, so there are two possible bases of a parallelogram, and the height is the corresponding distance between the opposite parallel sides, which you have considered as base. I hope this video and solving the 4 example problems will give you a good insight, an idea about calculating or finding the area of a parallelogram. So if this video was beneficial, please like it, share it with your friends, and once again please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. In the next video, I will discuss about how to find the area of a rhombus with some example problems. So please stay tuned for that. I will end the video here. Thanks for watching, and until the next video, take care and bye.